Hello, my name is Mike Booth, and I'm the Technical Director at Inorganic Ventures. This presentation will serve as a very quick introduction as to why clean eluents are important for ion chromatography analysis. Before we discuss the cleanliness of the eluent, it is important to understand what the IC eluent can affect. The concentration of your eluent will have a big impact on the retention times of your analytes. Generally, the higher the concentration of eluent, the faster your analytes will elute from the IC column. If you are creating a new method, choosing the correct concentration of eluent is key to have good separation of analytes but not have an excessively long runtime. Once your method is set or locked in, you want to make sure that each new preparation of eluent is consistent. If the concentration of eluent changes, your retention times will also change. The eluent also controls the background conductivity of the instrument. Again, the higher the concentration of the eluent, the higher the background conductivity. We will show examples of how high background conductivity can impact instrument sensitivity and detection limits. Our first example shows normal eluent flow through the IC instrument with clean eluent. I apologize for the rough animations, but imagine the blue circles representing the eluent flowing into the column and producing a flat conductivity reading. This is what you should see when you're letting your instrument equilibrate or run idle. Our next example will show a system with clean eluent running a sample containing fluoride, chloride, and nitrate. You'll see the sample enter the column at the same time and elutes separate from each other. So you're looking for the purple square, the green triangle, and the yellow circle representing fluoride, chloride, and nitrate respectively. Now that you've seen how a clean system will operate, let's take a look at a system running with contaminated eluent. The nitrate contamination is illustrated by the yellow circles mixed in with the blue circles that represented our normal eluent. You should see the same flat line as a system running clean eluent, but the background conductivity will be higher as you see in the red graph compared to the blue graph. Lastly, we will look at an example of sample being run on a system that has contaminated eluent. Again, you will see the sample get separated in the column, but if you look at the comparison of the blue and red graph, you will notice something interesting. If you overlay the graphs, you will see that the peaks are smaller when using the contaminated eluent. The baseline in this example still looks the same because some instruments will auto-zero or background correct the data as samples are injected into the column. This auto-zeroing or background correction creates a nice chromatograph because your background conductivity always starts at 0, but you'll have to dig into the data to see the uncorrected conductivity readings during your run. So let's review how to avoid these contamination problems. First, you want to start with clean starting materials. In this case, the eluent concentrate and water. If those are contaminated, then nothing else you do to protect against contamination will really matter. Secondly, we have found a good way to avoid contamination in our lab is to separate everything used to make up our eluent dilutions. We have kept some lab equipment designated for eluent preparation only. We also keep a separate container of DI water that is used only for ion chromatography. Finally, I would recommend keeping a detailed maintenance log that tracks background conductivity and when new dilutions of eluent are prepared. This information can save you a lot of time in troubleshooting if you run into a problem during instrument analysis. This concludes the presentation on the importance of clean eluent for ion chromatography analysis. If you have any questions, please don't hesitate to reach out directly to our technical support team. I would also recommend checking out the technical resources at our website. Thank you so much for your time and attention.